Today we're going to learn how to use ratio tables to find equivalent ratios. So equivalent ratios are two ratios that describe the same relationship. Those are called equivalent ratios. And equivalent is just a really fancy word for saying equal. So for example, if we had a ratio 6:3, okay, we could simplify that ratio by dividing each of these numbers by 3 to get 2:1. We could make that ratio larger by multiplying both of those numbers by 2 to make it 12:6. These are all considered equivalent ratios because it all started with that one ratio that we are changing by the same number. So kind of like what I just did, you can find equivalent ratios by multiplying or dividing each number in the ratio by the same number. Now that's super important. Every time I did something to the 6, I did the same exact thing to the 3. I can't do like times 2 to the 6 and then do times 3 to the 9. That doesn't keep that ratio equal. It actually changes it. So that wouldn't be an equivalent ratio. It has to be by the same number. We can organize equivalent ratios really neatly in a ratio table, and that's what we are going to be doing today. We can also find like missing values from a ratio using that table as well. So I'm going to show you two different ways that you can use ratio tables. Okay, one way, this first way is just building upon that first ratio. Okay, so we have this first ratio of pens to pencils is 1:3. So our first ratio is pens to pencils 1:3. We already have that from that table. Okay, on the top we're counting by ones because that ratio is starting at a 1. So we're going 1, 2, 3 would be that missing value. Now look at the bottom for the pencils. We're counting by 3, so think to yourself, what should go in this box if we're going 3, blank, 9? That should be a 6. So if we're pulling out ratios of pens to pencils, another equivalent ratio would be 2:6, and the last equivalent ratio in this table would be 3:9. Okay. The other way we can use ratio tables is by multiplying and dividing. So instead of just building that ratio table, we can go straight to a number by multiplying or dividing. So for example, I can go from 6 to 12 by multiplying by 2. And whatever I do to one number, I have to do to the other number. So whatever I do to the cats, I have to do to the dogs. If I multiply the cats by 2, I have to multiply the dogs by 2 to keep the ratio equivalent. So I would do 4 times 2, which would give me 8. Now I'm looking at that last column and I can't go from 12 to nothing. So I look on the top and I have 8 and 24. So I think 8 times what is 24? And I'll give you a minute to think about that. It would be 8 times 3 is 24. Whatever we do to the dogs, we have to do to the cats. So we would do 12 times 3 to get 36. If I'm pulling these ratios out, I have 4 dogs to 6 cats. Think about what my next equivalent ratio would be using that middle column. You should be writing down 8 to 12, 8 dogs to 12 cats. And then write down that last one from that third column. It would be 24 dogs to 36 cats. Okay, so you can either build that table or you can multiply it. I'll show you both ways on the examples that we do below. You're making sugar water for your hummingbird feeder. The website indicates you use 4 parts of water for every 1 part of sugar. So to make sugar water, we have to mix water and sugar together. And the website is telling you how sugary to make it. Okay, we don't want to put a whole bag of sugar in a little bit of water. It's telling you kind of like the recipe for it. So we want 4 parts of water for 1 part of sugar. If we use 20 cups or 20 parts of water, how much sugar do we need? Okay, so the first thing we do is we fill in our initial ratio. That initial ratio is the ratio that they give you at the beginning. That's what that recipe is going to be. So for water, we have 4, and for sugar, we have 1. Now for this example, let's start by building that table, and we want to get to 20 cups of water. So I put the 20 on the top because the water is on the top. They want us to get to 20 cups of water. So let's build that table. On the top, we're going to count by 4s. So we're building it. We go 4, 8. Think to yourself what these next 2 would be if we're counting by 4s. Should be a 12 and a 16. Down below, we're counting by 1s. So you can start filling in those boxes. You guys can all count by 1s. Should be 1, 2, 3, 4, 5. Okay, they wanted to know how much sugar for 20 cups of water. Well, when we have 20 cups of water, we need 5 cups of sugar. And that would be our final answer. Okay, we could have also done this by multiplying. We could have gone straight there. So if I just, and you don't have to write this down, I just want you to watch. If I've got my water and sugar, and I've got my 4-to-1 ratio, and I'm trying to get to 20 cups of water, I can go straight from 4 to 20 by multiplying it. And think to yourself, 4 times what is 20? Should be times 5. Whatever I do to the water, I have to do to the sugar to keep it equivalent. So if I do times 5 down here, I would also get the answer of 5. On a quiz or test, you would be able to do this either way, whichever way you prefer, if you want to build the table or if you'd want to go straight there. Okay. I'm going to just erase this so that we can see. So let's do another one. We're mixing paint together. So we're mixing blue and yellow paint. And I'm sure at some point in art class you learned that blue and yellow together makes green. So we're making some green paint. And to do that, we mix blue and yellow. But we want a certain color of green. And you get only a certain color of green by mixing so much blue with so much yellow. It has to be like a perfect combination. The more blue you do, the darker it's going to be. The more yellow you do, the lighter color green it's going to be. All right, so we'll start making that table with yellow and blue paint. We'll fill in that first initial ratio from the information they give us in our table. Go ahead and do that. We should have the 4 next to the yellow and the 2 next to the blue. We want to get to 10 pints of blue. So we're going to start again by just building that table. Let's build the blue because we want to get to 10, and then that'll tell us when we can stop, because once we get to 10 blue, we can stop. So 2, 4, 6, 8, 10. And once we get to 10 pints of blue, we can stop. For yellow, we have 4, and we're counting by 4s. 8, 12, 16, 20. The question asks, how much green paint do we need? So we also need a third row in this table that's talking about the green paint. So I want you to think back, and it doesn't tell us how much green paint we have in our initial ratio, but think about if you're mixing 4 pints of one color with 2 pints of another color, and we're just mixing those together, think about how many pints of paint we would have. Okay, it doesn't matter the color. We would have 6 pints because we'd be putting the 4 with the 2. We'd be adding those 2 together. So we can go through and we can add up those columns to see how many pints of green. So 8 plus 4 would give us 12. 12 plus 6 would give us 18. 16 plus 8 would get us 24. And lastly, 20 plus 10 would give us 30. So when we have 10 pints of blue, the question asks for how much green we have. color's not changing. There we go. The answer would be 30 pints of green. Okay. Now I'm going to take a different color. Let's do blue. And I'm just going to show you how you could have done this without building the table. Okay, because we could have gone straight there. We can go straight from 2 to 10 by multiplying by what? Think to yourself, 2 times what is 10? That would be 5. So we would do the 2 and the 4 and the 6. We'd have to do the same thing to the yellow and the green. So we would do 4 times 5 to get 20, and 6 times 5 to get 30. So you didn't have to build that table up. I'm just showing you, you could have also gone straight there, depending on your preference. I like to show you both ways because it's going to be up to you to choose how you want to do that. Number 3. Oops. I want that to be black again. There we go. Number 3, the nutrition facts label on a box of crackers shows that there's 40 milligrams of sodium in every 4 crackers. So our label here is going to be sodium and crackers. First thing we're going to do is fill in that initial ratio, so take a minute and do that. Put in your sodium, put in your number of crackers. The question asks, for 15 crackers, how much sodium do you have? So we're going to want to get to 15 crackers. So I put my 15 down where the crackers is, and I didn't put it right next to the 4 because think to yourself, we can't go straight from 4 to 15 by multiplying by something, because 4 times 3 is 12 and 4 times 4 is 16. So there's nothing we can multiply 4 by to go straight to 15. So sometimes we're going to have to divide these fractions to get it smaller, so that then you can take that number and multiply it to get it up to 15. So if I'm looking at 40 and 4, and I'm thinking, what can I divide both of those numbers by? I could divide them both by 2, but then for the crackers, I would get 4 divided by 2 is just 2, and I can't go from 2 to 15, so that doesn't really help me out. So I got to think of another number that I can divide both those numbers by. Another number that I can divide both those numbers by is 4. And when I divide 4 divided by 4, I get 1. And once I get that 1, I can get that back up to 15 by multiplying. And we'll do that in a minute. But first, whatever we do to the crackers, we have to do to the sodium. So we're going to divide both of them by 4 to get 10 grams of sodium in 1 cracker. Now think to yourself, 1 times what is 15? Well, can we multiply by 1 to get 15? And then whatever we do to the bottom, we have to do to the top. So go ahead, work ahead. I would multiply 1 times 15 to get 15. On the top, I would do the same. 15 times 10. Remember, I could take 15 times 1 to get 15, and then just add in my 0 to make it 150. You could also stack those numbers and multiply them out if you would like to do it that way as well. Either way, you would get an answer of 150. Final answer would be 150 milligrams of sodium. Okay, so sometimes you can't build that table. Sometimes you can't go straight there. Sometimes you're going to have to kind of work with it a little bit in order to get it to a number that can get you there. Okay. All right. Let's set this table up kind of together, but then I want you to start trying to do some of these on your own, because on your homework, you're going to have to do it on your own as well. Okay. So your neighbor pays $15 for every 2 hours you work. You work for 8 hours on Saturday. How much does your neighbor owe you? So we start off by writing those labels. Well, we're talking about money and hours. I want you to start filling in that first ratio. How many dollars for how many hours did they tell us? We should have $15 for 2 hours. And we want to get up to 8 hours. So if we're building this table, we'd count by 2's on the bottom because we're trying to get to 8 hours. We want to count by the 2's so we know when to stop. 4, 6, 8, and there I'm at 8 hours. On the top, I'd count by 15, so it'd be 15, 30, plus 15 more would be 45, plus 15 more would be 60. So we could get our answer there. It would be $60. You could have also chose to jump straight there. You can go from $15 for 2 hours straight to 8 hours by multiplying by 4. So you could take 15 times 4. 5 times 4 is 20. 4 times 1 is 4, plus the 2 is 60. So you could do it that way as well to get your 60. Either way would be correct on a quiz or test. Okay. Again, I want you to try to start setting up this problem on your own. I'll talk slow to give you some time to start doing that. And I'll read off the problem. A grade has 81 girls and 72 boys. The grade is talking about like 6th grade, 7th grade, 8th grade, not like an assignment. So a grade has 81 girls and 72 boys. The grade is split into groups that have the same ratio of girls to boys as the whole grade. So what they're basically doing is they want a smaller group, but they want to keep the same ratio of boys to girls. How many girls are in a group that has 16 boys? Use the ratio table to solve. So we should already have started writing out our labels. Labels should be girls and boys. We should have started putting in our initial ratio, the first numbers that we were given. We should have 81 and 72. We want to get to 16 boys. Okay, so going straight from 72 to 16. This is one of those that we can't build, and it's really hard to think about like what could I do to go straight from 72 to 16. That is not mental math for me either. So what I'm going to want to do is make these numbers smaller. Okay, by dividing, and then I can work with those smaller numbers to get it back up to 16. It's easier that way. So if I'm looking at 81 and 72 and I'm thinking, what can I divide both those numbers by? You can work ahead if you already know. I want you to especially look at that 81 and think, what can I divide 81 by? And then check with 72 if you can divide it by that also. And it's going to be 9. So go ahead and divide both those numbers by 9. I'll give you a minute to fill in your table if you haven't already. $81 divided by 9 would be 9. 72 divided by 9 would be 8. And notice how now that we have smaller numbers, we can get that 8 up to a 16. And we get that 8 up to a 16 by multiplying by, and work ahead if you're ready to go, multiplying by, think to yourself, 8 times what is 16? It'll be 8 times 2. Whatever we do to the bottom, we have to do to the top. So we would do 9 times 2, and that would give us a final answer of 18. Go back up to the question and ask what they look at what they asked for. How many girls are in a group that has 16 boys? Well, here's where we have 16 boys. So we look above it to see how many girls there would be. There would be 18 girls in that group. Okay. Take a minute, write a short little summary, just summarizing what you learned today about ratio tables. And then you can get started on your homework.